and people cannot concentrate. So unless you have to go to the bathroom or an emergency, if you plan to leave earlier, I would ask you kindly to sit on the back. So when you leave, you don't create commotion for the other people to go to concentrate. And we're going to do an old exam, winter 2009. At the end of the exam, the average was very high the first time. We had quite a few hundreds, I think 7 of them. So this time it's not going to be the same thing. We've got to get a little bit harder. So there is a problem at the end, which is actually 15 points. And unless you have time, do everything else first, then that, okay? I'll send an announcement too. So don't try that problem unless you really have tried everything and you're done with it. Then if you have time, still time, try that. Because it's kind of a little bit challenging. Okay? Pretty cute problem. See how many people are going to do it. 2 post creation. All right. So there's a lot of similar problems, right? And like I said, there is so many resources that you can use and already have done it, right? Make sure you read all your notes really well. You do all the problems we did in class, everything in the reader. You seem to know everything in the reader. Problems, do all the problems, and there are not that many, so you should do all of them. And then if you have time, see the practice exams, videos, and hard copy online. And if you have time, then you can read from other books as much as you want, okay? That's the order to do things for this class anyway. So let's start with the first problem, which is a precipitation reaction problem. As we said, on the back of your exam, you will have the solubility rules, and the only thing you need to do is to really know how to use them, okay? So here is the solubility rules. They are on the back of your exam. So if you have done already, because you've done it already, you know how to use them, then these kind of problems should not be any, they should not give you any challenge. So here's the first problem. So take a few seconds to think about it and tell me the answer, and then we'll talk about it. That is one way you can see this problem. There's another way this problem can be given to you, and I think, if I remember well, yes, I do. The exam, it will not be this format in the exam. In the exam, it's going to be a bunch of ions and cations, this, comma, that, comma, that, comma, that, comma, that, all together as a soup. What is going to form? If it's going to be anything form, right? It's the same thing. You're mixing solutions, right, with these ions, or you assume all these ions are in solution, what's going to happen? Same thing, okay? Just different way of giving it. So the easiest way to do this type of problem is, well, in this case, the way it is, you will not do it the same way like I said before. So maybe we can do the same both problems. So for this one now here, what do you see? That's the acid, this is the base, that's a neutralization reaction, right? So what is it going to form? Ammonium chloride, right? What's the answer? First of all, how many people say A? Raise your hands. A, B, C, D, E. Okay, so you got it. So how many people want me to talk about? Raise your hands. Don't be shy to answer when I say that, because, you know, if there's a lot of people, I'll do it. Otherwise, I'll do it at the end. Answer your question at the end. So how many people want me to do it? Raise your hands. Okay. So the first one is a neutralization reaction. We do know that H plus from here is going to go to ammonia and give you ammonium ion, and that's very chloride. Here is going to be ammonium chloride, right? So you will have ammonium chloride. The product will be ammonium chloride. And if you go on the back of your exam, you will see that all ammonium salts are soluble. Okay, so that's not going to precipitate. So no reaction, you know, no precipitation reaction. It's a neutralization reaction, yes. There's a reaction happening, but it's not precipitation. No precipitation will form. Or the salt will be soluble in water. Same thing here. You have potassium hydroxide, sodium chloride. What's going to happen? There's base and salt, right? Base and salt. Normally should give you base and salt, but in this case, really, when we do these two solutions together and you see aqueous, already you know that these are soluble, right? These are soluble and this is soluble, right? We know that. So the combination that you need to think about is this is plus and minus, this is plus and minus, right? Each part has a plus part, each formula unit, right? Has a plus part and a minus part, correct? So plus here with minus there, that will give you potassium chloride. But all chlorides are soluble. And then you have sodium hydroxide. Sodium hydroxides are strong base, soluble. Strong electrolyte, soluble, right? Remember that. So again here, nothing will happen. The same thing here. Nitric acid and base, that's the neutralization reaction. And the salt will be water. Plus from here, minus from there will give you water, right? And lithium plus and nitrate minus will give you lithium nitrate. Yes? And all the nitrates are soluble. So forget about that. This will give you water, right? No precipitate. And so here, you can see plus with minus will give you potassium nitrate. That's soluble. But silver chloride, if you go on the back of your exam, you will find out that it's insoluble salt, right? So that's the way you do it. Now, let's say that the problem was giving you in a different way. Let's say you had, let's do this problem in a different way, right? So let's say it was potassium plus, right? Nitrate, silver plus, and what else? Silver minus. So let's say you have all these ions together in solution. Same problem, but in a different way, right? So you have all these ions in solution, and the question is, will any precipitate form? So what you do is, the easiest way to do it fast would be probably you put the ions on one side, and you put the anions on the other side, and then you say, because now it's not given to you like this, so you don't know if this is soluble and that's soluble, because it's, you know, isolated, right? So you don't really know. You have to look on all the possible combinations, right? So this one with this one will give you what? Potassium chloride. Chloride is alkali salt, first group, right? And chlorides are soluble. So this one is not going to be. And then this one without one, nitrate salt. That's not going to be. It's in other words, it's soluble, right? It's not going to be a nitrate. This one, with this one, it's a nitrate salt. That's not going to be precipitate, right? And the only thing that remains is this, which, as you can see, silver chloride from the back, you will see that it's insoluble. So, then you say that when you get all this together, this salt that will precipitate will be sodium chloride. So, it's just a little bit different way of doing it, right? Basically, you're doing the same thing, it's just a little bit small different, yeah. Okay, let's see the other one. So the other one, well, let me take a few seconds to read it, right? You see I changed that word ionize because that's not exactly correct. A lot of authors do that mistake, and sometimes I'm doing it too. But when you have salts, they are already in the form of ions in the crystal lattice, right? So it's not really ionization, producing ions, it's dissociation. The ions dissociate, they are not created. Yes? So that's why I changed that from there. Have you seen this exam before? Huh? I tried to not to do the same things that is online. I hope I didn't make a mistake, so it should be in order, right? Okay, so A, let me see your hand. A. Oh, good, so we don't have to do it. Right? So everything is wrong except what? Number A, right? How many people want me to do it? Let me see your hands. Okay, if you have questions at the end, right? So if I see, 2-3% or something, at the end I'll be available to answer your questions, okay? If it's not many that they want me to do it. Okay, let's go to the next one. Number 3. That's not hard either, right? I think that's an easy one too. Remember that nice diagram in the reader? It shows all together in one place. It's very useful because you can remember them all together. And when you go to organic chemists usually define oxidation reductions by talking with hydrogen and oxygen, you know. Receiving hydrogen or oxygen or losing hydrogen or oxygen. Because a lot of reactions, they involve picking up or losing hydrogen and oxygen, and they're using these terms, organic chemists, almost all the time. So that's why I want you to be prepared for organic. I do a lot of things to prepare you for organic. So, how many people say A, B, C, D? Okay, so how many people want me to do this? Okay, it's an easy one, right? Huh? It's the definitions, really. I mean, there's not much to explain here. You have to just remember that. Okay? We can already say much to here. You just have to remember from that diagram, right? Altogether, yes. Huh? So the answer for 3 is D, right? D. So maybe I should just put it down and reprint again this one. Let's see. So 1 was E, right? And 2 was A. Anyway, don't have time to put them to write them down to this. 3 was D. So let's do the 4. Oh, that's an easy one. That's totally easy. That was a bonus point, right? Bonus. Right? Huh? Explain 4? All 3? No, that's reduction. Okay? I think we gave something to remember. What was it? Kind of acronyms of something? Oil rig. Huh? Remember that? I forgot about it. Oil rig. Oil rig. Remember, oil rig. Then you will not forget that again. Okay, so 4. Everybody knows 4, right? How about 5? What happened? I touched it again. Ooh. Whoa. Yeah. Come on. Ooh. Incredible. Look at that. We're flying. 5. How would you do 5? You know by now. You might have to write a little bit down. Maybe you need to maybe write a few things down. Just looking at it. You can do it looking at it, but you might have to write things down, make this answer, right? So how many people say A, B, C? Okay, so it's very easy, right? How many people want me to explain it? How many? Come on, you guys don't be shy. Otherwise you will not get anything from tonight. Okay, I'll do it. So here it tells you what happens to the, because this kind of problem might be in different forms. Many ways to do this type of problem, right? So it says what happens to the volume of the gas when both its pressure and temperature are doubled. So it talks about a gas, P, V, T, blah, blah. So what do you need? You need the ideal gas equation, right? And it says what happens to the volume, so I solve for volume. Volume will be equal to nRT divided by pressure. So it says that its pressure and absolute temperature are doubled. Its pressure is doubled. So now, from this one, right? This is V. And this is the new one. It doesn't say anything about number of moles, so it does the same, you don't know, you assume it's the same, okay? The temperature is doubled, so it's going to become 1. And the pressure is doubled, so it will become double. Yes? So this goes away, and you can see it's exactly the same like this one, so the volume stays the same. So if you know how to do this, the problem can be in very different ways, right? Sometimes you can only get an answer if it doesn't tell you arithmetic values. Like, let's say the volume is here, right? Like this. Okay, so now let's say you increase the temperature, okay, and you decrease the pressure, and you increase the number of moles. What will happen to the volume? So you know what will happen because all of these changes lead to the same direction of change for the volume, right? So the net result will be the same as everything points out to be. Everybody got it? If you have one of these, let's say, going up, right? So if you increase temperature, you increase number of moles, and increase pressure, what will happen to the volume? You cannot answer. You don't know. Because this makes it to be lower, and these two make it go larger. The only way you can answer it is to have the numbers. How many times you increase and how many times you decrease. How many times you increase each one of them. Otherwise you will not know. Yes? Okay. So you know this type of problem. Okay, let's go for the other one now. No, it's actually that one is this problem actually has 2 answers, so I think when I did it probably didn't see it. So it has 2 answers. Which are they? What? C and B, huh? C and D? I thought you would get it. Maybe you did. Huh? Wait a minute. What's number 6? Each of the following yeah, which is the... Oh, I thought, let me see. So, how many people say A? B? C? Yeah, how many people say B? I said there's two solutions. You already know now, right? How about D? E. Both are correct, B and C. Both of them, they talk about orbits. You remember the key points of each theory. What? D? D talks about orbitals. That the electron is found in a region of space. Possibility to find an electron in a region of space, not orbit. Right? Quantum mechanics, not classical physics. Big difference, right? Okay, let's go to the next. Yeah, This problem is actually relates to that first page of the reader, remember, about force, distance, and energy. Very incredible relationships between these three. Always we are talking about it. Did you notice it? We won't stop talking about it until we finish. We'll talk many times about this. It's always coming up in every lecture, many times. Even if you go to 2B and 2C, still we will be talking about the same thing. That's why I put in the reader, not in a chapter. Before everything starts, I put chapter. Because I see so many students not understanding a lot of things because they're missing this knowledge about the relationship between force, distance, and potential energy. And it's so easy to read it there, piece of cake, right? With a magnet. And then you can apply that for so many things. 2B, 2C, organic, all the time. So what's the answer for this one? A, B, C, D, E. Ah. Wait a minute, you guys. How many people say A? B? How many people do not know? Let me see your hands. Don't be shy. How many people know? Didn't you read that thing from the reader? No? What does it say? Consider the hydrogen atom in its ground state when the hydrogen atom becomes excited. Okay, so when the hydrogen atom becomes excited, what happens? Energy is absorbed by what? The electron. It goes to a higher energy state. Excited means higher energy state. So here is plus and here is minus. If it goes to higher energy state, that means that now the electron is going to be farther away or closer? Farther away. Why? Look, plus minus, they attract each other. I can already pull it. That work that I did, that energy, the form of work I did, is stored in the system of the nucleus and the electron, the atom. And for convenience, we say the energy of the electron is higher. It's the same thing. Exactly what this says is exactly the same thing. If I take the chair from where it is now and I put it there, now the chair has higher potential energy than it had when it was closer to the center of the earth, right? Rightly speaking, you would say the system Earth and chair and the surroundings. Earth and chair have higher potential energy. Where do they get their increase of potential energy? From me, from the sun. Food digestion, right? That energy came from the sun, ultimately. And for convenient reasons, we say the chair has higher potential energy than before because it's farther away from the center of the earth. But really, whenever we talk about potential energy, it has to do with two things, repulsive or attractive forces. So it's the energy of the system. But for convenience, we say the energy of the chair or the energy of the electron is higher now, right? Everybody got it? Okay, if it was plus, plus, or minus, minus, like two electrons, then it would be the opposite, right? If minus, minus is there, two electrons, right? If you bring them closer together now, it's not going to be less energy like before. Now it's going to be more. Why? Minus and minus repulse each other. Make it from here to there. Again, I have to push it. So now all that energy I spent, it's stored in the system with closer distance. Minus, minus. To left, right? That's why I told you it's so important to really read this 1.5 page. Still, a lot of people you missed it. That means you have not understood yet that kind of thing. And it's really important. So the answer for 7 should be B. Okay, let's go to 8. What's the answer for 8? And then I can, I'll play for you a reminder during the break. A great reminder. some of my students worked about. They made the 15 minutes only 3 minutes thing. I want you to remember that reminder. Okay, what's the answer? A, B, C, D, E. Okay, that's an easy one, right? So the answer should be B. It's not any kind of mystic thing here to say. This one could be confusing. It shouldn't be confusing, but some people might miss it. Really, quite a few people might miss that one. Whenever you talk about density of gases, it's a little bit challenging, right? Because you need to take into consideration that one property depends on other three properties. And you have to be quite careful when you talk about gases, how one property changes as a function of others, right? And you must understand this gases business, because when you go to 2B and you do thermodynamics, thermodynamics is using all the time gases to teach the concepts. It's concepts, the thermodynamic concepts. You use gases most of the time. And you need to understand the behavior of gases with the laws, otherwise it will be challenged. So what's the answer for 9? A, B, C, D, E? No good answers. How many people do not know? Raise your hand. Come on, come on. Come on, we're not going to grade you tonight. All right. So how would you do this? It says that you have a gas in a closed container with a fixed volume. So here is a volume V. Fixed. That means it doesn't change. Or you can assume the cylinder with a piston device that I usually use, right? And it's locked. It cannot go up and down. This volume is constant, not changing. All right? And what do? You double its absolute the temperature, so from 300 becomes 600 Kelvin, right? You double its temperature. And it says the density, what will happen to density? So density, what will happen? Okay? So you shouldn't really miss this. You must focus. When you're asking something, you focus to that. You're looking for a pen. In this room, you're not looking for a mouse, because you will not see the pen even if it's in front of your eyes. Don't you agree with that? Yes. So you're looking for density. So now, don't think about anything else. Think about density. How is density defined? What's the definition of density? Okay, let's put it down. So density is mass divided by volume. Now what mass? The mass of the container? No, we're talking about the density of the gas. So it has to be the mass of the gas divided by the volume of the container. I would say you better say the gas. And that is the volume we assume of the container inside, right? All right, so what happens to density? We will conclude if we figure out what happens to the mass of the gas and the volume of the gas. So you are increasing the temperature, but the volume says is fixed. And what happens to the mass when I increase the temperature? Nothing. I didn't put more gas in it or lose gas, so the mass is the same. So what will happen to density? Oh, now you know. Why you didn't know before? Because there was no focusing. That's why. Not because you couldn't do it. You could do it. It's because you didn't focus. That's why. So focusing is extremely important to be able to focus. Here's a good one. Super creation. Again, should I say the same thing? I don't remember where I said it. To the two superior clay people. It depends on your current perception of reality. So that happens in the evaluations too. The teacher sees that many times. So one student will say, I love my teacher. He's a great teacher. He's telling me how to become creative. I see he has become a creator because he tells us that he's making these problems and he's enjoying them. To watch them and talk about them, he's proud of what he created. And he's very joyful about it, very successful.